This video is on how to find the domain and range of a function, of a graph. First, let me give you the definition of domain and range. Domain is what can x equal in my function or in my graph. What can x equal in my graph? Range stands for what can y equal in my function, your function or your graph. Okay, so the first function I'm looking at is a line segment. It actually stops and ends. It stops and ends. So domain, to find the domain, is you can actually draw this vertical line right down, and you from here to here. And remember, x is your horizontal axis. So if you look at the horizontal axis, right at this point, this is where the x's start, and this is where the x's end. If you look at the graph there, this is where the x's start, and this is where the x's end. So my domain for this graph, it starts at, this is 2, it starts at a positive 1 and ends at 6. Now, since it does equal 6 and it equals 1, we're using brackets. So my domain for a linear equation here, the x's start at 1 on the graph, and they end at positive 6. Now, the range is what can y equal. Now, if we look, where does the y start? At the bottom. And you draw the horizontal line. Sorry, when I draw this, my graph moves. I'll move it back. And it ends up here. The horizontal line ends up here. Could have did it in black here. So here's the horizontal lines. Now, the lowest part of the y is down here, which is at negative 3. So my graph, the lowest part is negative 3. The highest part for the y is way up here at 12. See, my graph starts y3 and ends at y12. This is all where my graph starts and ends, from negative 3 to positive 12. And negative 3 and 12 are part of the answer. So my domain is where the x starts here and it ends here between 1 and 6. Range is about the y. It's negative 3 and ends at positive 12. Domain starts at 1 and ends at 6. Domain is the x, where the range of where my x is at. Range is the area where my y's are at. Okay, so let's try this next equation, this next graph. This is a parabola. Now, on all parabolas, they don't have endpoints. These lines, it doesn't show it, but these lines go up and up. There's an arrow. This should be arrows at the end of this. It shows a parabola going up and up and up. So the domain of this, we want to know where the x is at. Now, if I draw this, trying to move it over. If I draw this x-axis right here, my graph does not end there. My graph does not end there because of the arrows. The arrows go up and over, and they keep on going up and over and up and over. Do you see? It keeps on going up and over and up and over. So where does the arrow end on the far left? Well, it keeps on going up and to the left, up and to the left. In other words, it goes all the way over to negative infinity. Negative infinity is all the way to the left. This graph keeps on going to the far left. Now, the other side, it keeps on moving to the right and to the right and to the right. It keeps on going. The arrows mean to keep on going. So that goes to positive infinity. So domain stands for what can x equal on this graph. It starts at negative infinity on the left because it keeps on going up and over to the left, and on the right it goes to positive infinity. So there are no restrictions on the domain here. X can equal anything because this graph keeps on going up and to the right and left. So the domain is negative infinity, positive infinity. Now the range. And we always put parentheses when you can't touch. So we can't touch infinity, so that's why we're using parentheses instead of brackets. Now the range is the y's. And if you look, this is where the y's start, right down here. So the y's start at 2. So for my range, the lowest part is 2, and then it goes up and up and up. You see the arrows make this graph go up and up and up, so there's no limit. So going all the way up, it goes to infinity. You never touch infinity, so we have a parentheses. We are touching 2. 2 is actually a point, so that's why we use a bracket here. So the range, the lowest point is 2, the highest point is infinity. Domain, you both have negative and positive infinity for this. Okay, let's move on. The V-shaped graph, the absolute value graph. What is the domain? Once again, you should have arrows on here. This graph goes on and on and on. In other words, it goes to the left, all the way to negative infinity. It goes to the right, way over here, all the way to positive infinity. This graph keeps on going to the left and to the right, all the way to positive and negative infinity. That's the domain. The range, where it's the lowest point is at 0 down here. The highest point, well, it keeps on going up and over, so it keeps on going up and up and up. So the range is infinity. The highest point is infinity. So this is the domain and range for the absolute value function. And I have one more, the square root function. This is the square root function. Domain, where does, by the way, this has an arrow. If I can get it there again. This actually has an arrow, and it keeps on going. It's actually I'm trying to draw it without it moving. So it keeps on going up and to the right. It keeps on going up to the right. So the domain, it actually does start at this first point right here. This is 1. So the domain starts at 1. You see how this is 5, 2, 3, 4. And then it ends, it keeps on going to the right all the way to positive infinity. So this is the domain for this graph. It starts at 1. The x's, remember, domain is what x can equal. It starts at 1, and it goes all the way to infinity. Now, if your graph doesn't have this arrow, it should. All absolute value graphs have this arrow that tells it keeps on going to the right. The range. The lowest part of the range is 0. You see it down here at 0. It starts at 0. And how far does it go up? Well, this graph is going up and to the right. So it's always going to be going up a little and to the right a little. So it goes up as far as we can because that arrow says it keeps on going, and it goes to infinity. This is how you determine the domain and range of different functions. I hope this video helped.